Thanks everyone for being here. And today we're just going to be covering 12 very important functions within Excel that you will certainly find it useful in any form of data analysis, whether you choose to work a like finance or like any other quantitative role. Excel is extremely important, and we basically picked out 12 different functions that will be useful in the widest range of scenarios, and is also relatively beginner friendly. So since everyone here, I'm guessing, like, judging by demographics of ASS and MUMS, everyone's probably a STEM student or like studying math or actuary. So definitely have to don't have to be intimidated by the difficulty, because it's probably going to be easier than the stuff that you already learned. So, but please still do pay attention, as I understand that a lot of you might be new to using these Excel functions. But anyways, let's without further ado, let's get right into it. So the first function that we're going to be looking at is a relatively simpler one. It's the if function, very similar to if statements in like programming languages, if you ever had exposure to those. So what it does is basically checks if the data meets a certain criteria, and you can define what this criteria is, and it outputs something. It outputs one thing if the criteria is met by a certain data set or like data point, and it outputs something else if the criteria is not met. So this will be best shown through an example. Okay, so now let me just switch the shared screen to our big document over here. It's a lot of data over here, but we're definitely not going to use all the data. We just sort of like found a large data set that so allow us to really play around with it and use a lot of these functions which are like applicable to this. So it's basically a list of Netflix shows along with their ratings levels, release years, and a plethora of other criteria, other data. Okay, so if we're going to use our if statement, so just label it if. Okay, so in any function within Excel, to use it, we have to first put a equal sign and then call the function. So if and then brackets. So what goes inside the brackets are called arguments. So by changing the arguments, you sort of change the output that the function gives. And let me just go back to the if statement. So as you can see, the if function takes 3 different arguments. So the first one is the criteria. So basically, this is the criteria that's going to check if it is met by the data points. And after that, you have to include the output that you want if the criteria is met. And after that, the output that you want if the criteria is not met. And each of these 3 arguments is separated by a comma. So to put that into action, okay, all right, let's say what we want to do is we want to take a look at the ratings level, let's say. And let's say that a rating of 60 or below is considered family friendly, and anything that is 60 that is above 60 is considered maybe too violent, like not family friendly. So if we want to check if all these shows, which of these shows are considered family friendly, and do something like, okay, so since we are wanting to check the ratings level, we have to look at which cell this data is in. So we can say that I can see that it's in row 3 of column D. So I'm going to put D2, sorry, row 2 of column D. All right, D2, and then the criteria is less than or equal to 60, right? Because if it's less than or equal to 60, we consider it family friendly. Otherwise, it's not family friendly. So if it is family friendly, if this criteria is met, we can output yes. And otherwise, we can just output no. And let's try this. Yep. So as we can see, the first row has a rating level of 90, which is above 60, therefore not family friendly. And if we just drag this down, Excel is pretty smart. It knows how to apply this formula to the rest of the data as well. As you can see, later on, with each successive row, it checks if the data point in the following row is less than or equal to 60. So it automatically does, if you input D2 and drag it down a column, it just automatically checks D3, D4, D5, all the way down through however many rows you drag it down. Yeah, and it seems like it's pretty accurate for those that are, for those who have rating levels less than 60, less than or equal to 60. Yep, output's yes, family friendly, otherwise it's no. So something that's important about the if function is that the output has to be put in these quotation marks. So if we try taking away the quotation marks of one or both of these arguments, as you can see, yeah, it doesn't, it's like, it's undefined, it's an error. So I'll put back the quotation marks for these outputs. So yeah, fairly simple function to start it off. It has 3 arguments. First argument is the criteria that you want to check. Second argument is the output that you want if it meets the criteria, and then the output that you want if it doesn't meet the criteria. All right, cool. Let's move on to the next one. All right, the next one is it's called SUMIF. So basically, it's similar to the if function in the sense that it does something based on a certain criteria, except this time we're talking about summing together values, like summing together numbers. So let's look at its arguments. It also takes 3 arguments, except like it's pretty yeah, it's pretty hard to understand what it means by like column for criteria just by like reading it, but it'll make a lot more sense once I show you some examples. So basically the column for criteria is like the range of the data. So maybe you want to check this entire column. You have to select the whole column, say that this is the range of the data in which I'm going to look for whether each data point meets my criteria. And the second argument is going to be the criteria itself. And then the third argument is what we want to, the data that we potentially want to sum up, that we want to add together if it meets the criteria. So let's jump to an example. Usually for these things, an example just makes, like if you don't have an example, it seems very confusing. But once you see an example, you realize that it is actually, yeah, not that bad at all. So anyways, now we can have a look at this little section of the data here, name, state, and sales. It's basically the sales data for, don't know what product they're selling, but it's just like the sales data for like sales made by different employees in different states. So we have a Jim from Victoria, we have Sarah from Queensland, etc., etc. Yeah, we actually have 2 Jims, like Jim number 2 is from South Australia. And okay, so let's say we want to sum up all the sales that's made by Jim, right? So here are all the sales. But let's say we only want to find the sum of the sales. What's the total number of sales? That's sorry, total value of sales that's made by Jim, which is kind of funny because the 2 Jims that we have are actually in different states. So I mean, I don't know, like I don't know what a company would need to know. Like what's the total number of total value of sales made by this like people with this single name, even for different people. But who knows, maybe find out like people who are named Jim are just better salesmen. But anyways, we're going to say again, have an equal sign to apply the function. Sometimes you might forget to put the equal sign. It just doesn't make sense if you try to call a function. Make sure to the equal sign before that. Yeah, all right. So in case you've forgotten, the first criteria, the first argument that we want to look at is the column in which we're going to scan for whether the criteria is met. And since our criteria is whether people are called Jim, of course, we're going to be taking a look at this column over here. All right, so from I2 to I12. And if it's a huge data set, if it's like a huge column, you don't have to drag it all the way down. You can just say like, okay, I2 to like I200. Selects all the cells along that column for you. All right, for 2000 actually. Definitely don't need that. Just up to I2 up to I12. Okay, so this is the range of data in which we actually want to scan for whether the criteria is met. So obviously not every single data point in this range is going to meet the criteria, because not everyone here is called Jim. But this is just like the range of the data in which we expect the criteria in which we're going to scan for whether the criteria is met for each of these points. Okay, next argument is the criteria itself, which is pretty simple, just Jim. Remember to put it in quotation marks. If you don't put it in quotation marks, that means you haven't specified the criteria. Okay, now that we've specified the criteria, we can look at the range of values that we potentially want to sum up, which is just all these sales figures in this column. So K12. All right. If we do that, right, gives us 200. Let's check if that's accurate. So yeah, we only have two different people called Jim. Each of them has made sales of 100, even though the two different people, two different states. Yeah, like seems like our function is accurate. We managed to find the sum of the value of the sales, total sales that's made by people who are called Jim. So just going over this again, because it could still be confusing to some people. So the first argument is the range of the data in which we're going to scan for whether the criteria is met. So obviously we have to scan the names. We can't scan the state, right? Like we can't look for who is called Jim in the state of like Victoria, like Queensland, or like all these data. We have to look at the list of names and see which of these, how many of these people, which of these people are called Jim. Second argument, pretty straightforward, just the criteria itself, Jim. And another interesting thing is that it's not case sensitive. So you can actually, even though it's all the names are capital Jim with a capital J, if you put Jim with a lowercase j, it gives you the same answer. It still works. If you try like capital M, it doesn't make any difference. So it's pretty convenient. But I'm still going to change it back because I think lowercase j for capital M just doesn't look pretty. Okay, so actually let me just specify this. So I hope you're doing the same things, using the same functions as throughout the course of this workshop, so you can sort of keep it for your own reference in the future as well. Okay, and next up, let's say what we want to do is find out the total value of the sum of the sales that are made in the state of Queensland, let's say. So I'll make this quick since it is quite similar. So again, sum if, and this time we're not going to be scanning the names, we're going to be scanning the state. So this is the range of the values in which we want to check if the criteria is met, because our criteria is no longer a name, it's no longer whether the person who made the sale is called Jim, it's whether they are Queensland. Again, it's not case sensitive. I'm just going to put lowercase QLD to show that. And then, of course, the values that we want to sum up are, again, the sales figures. And it seems like we got 375 as the output. Let's check if that's accurate. Okay, so we have 3 sales from Queensland. One's from Sarah, that's 425, to the $50 sale made by Steve. That's 175, added to $200 made by Jamie. So yeah, seems like it's accurate. It's nice. Cool. All right. Now we can move on to the next function. All right. Count if. As you can see, it's a lot of ifs. So when you see an if, you know that it's like based on a certain condition. It performs a task, whether it's giving a output that you want, summing up data, or counting. It's all based on whether a certain criteria is met. Okay, so countif, this function counts the number of cells meeting a certain criteria. So it only takes 2 arguments instead of 3 like the previous 2. So it takes the column, again, the column in which we're going to scan for the criteria, and then what is the criteria itself. This function is very easy to implement. I will show you through an example. Yeah, okay. So let's say what we want to do right now is we want to, okay, check out the number of sales made by a gym. And so we want to find number of sales over 100, so over $100, or like number of sales in South Australia. Okay, so countif function. All right, so this time, like the first argument is similar to the first argument of the SUMIF function. We are going to scan for the range of data in which we want to check if the criteria is met. So what is the first criteria here? Sorry, what is our objective of the first one here? It is to find the number of sales at gym. So again, you have to scan for the names and see who is called Jim. And yeah, after that, we can input our criteria, which is Jim. Remember the quotation marks like always. And it says, yeah, 2 sales are made by Jim, which is obviously accurate because 2 people for Jim. And number of sales, that's over $100. Again, countif. And this time, since the criteria is related to the size of the sale, or like how large the sales number is, we're going to be scanning this column instead of the other 2. And then the criteria is simply greater than or equal to 100. Okay, it looks like there are 9 sales greater than or equal to 100. Let's check if that's accurate. That's 1. Oh, sorry. All right. It's greater than or equal to. So 100 itself counts as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's accurate. Very nice. And right, number of sales in South Australia. So again, we need to countif since we're looking at the number of certain things. We always use countif. And right, in this case, we're finally looking at state. So the criteria is related to which state the sale is made in. So of course, now we have to scan this column. And the criteria is just in quotation marks, South Australia. You can put in lowercase, so that works too. And it says there are 3 sales made in South Australia. 1, 2, and 3. Yep, makes sense. Okay. Yeah, sorry, it is a big data set. It's plenty of functions. So at the end, it might look a bit convoluted. So hopefully you're doing some of your own like formatting as we go. So that as well. This one is the SUMIF function. This one is the countif function. All right, let's move on to the next one. All right, trim. This is a interesting one. So it can do 2 things. It can normalize spacing between data. What is not meant by that is like, let's say, okay, let's say you're a school teacher and you ask your students to like fill out the names, the first and last name in the same cell, the big Excel worksheet. But some of these kids just don't want to make your life easy. They like, maybe they put like 3 spaces between their first and last names. Some of them put like 4 spaces. Some good kids, right? They did what every normal human being would do, put just one space between the first name and last name. But let's say the data is like, so what normalize means is that it sort of makes sure that the that all the data within that cell is separated by only one space. So over here, John Smith, he's a good kid. He he put one space between his first and last name. And Aaron Yeager here, all right, this kid is a bit special. He put quite a few spaces. Irene Lee put a few spaces, and also AJ. But that's why we use the trim function. Equals trim is pretty easy. It only takes one argument in this case. So let's say it takes John Smith, that is in column I and then row 16. Yeah, interesting. It doesn't change because John Smith is already normalized, so one space. And if we just drag it out here, yay, okay. The rest of the names are normalized as well. Cool. Oh, Carol, you raised the hand. What is up?
Can't see your screen. The one on the Excel.
Oh, my bad. Yeah, thanks. Oh, thank you so much for telling me that. Thank you so much for telling me that. Yeah, forgot to switch between the screens. Oh yeah, anyways, I was just looking at these this list of names. So you can see like John Smith is already normalized. Aaron, Irene, and AJ have some spaces, some extra spaces between their first and last names. But what I've done here is I use the trim function, and which only takes one argument in this case. So it just normalizes whatever's in the cell. John Smith is already normalized, and all the rest look much more neater now as well. Now that we've gotten rid of the extra spaces. So that's one way of using the trim function. There's also another way in which we can use it, which is to, so that's one way of using it, just one argument. And another way of using it is joining data points together. And each of these data points will be separated by a and sign. So to show you what that means, let's go here. All right. It's number 4, trim function. All right. So, all right, let's say what we want to do right now is we want to look at this, this big data set. And let's say we want to join the rating score, the user rating score, which is 62 for the first one. And as well as the user rating size right next to each other. So right now they're in two separate cells, the two separate data points. Let's say we want to make one data point which shows us both values. What we can actually do is to the side a bit. Okay. Yep. So it equals the first data point that we want to join, which is, okay, in column F, row number 2, the user rating score, F2. And then I can separate that and the other data points with the and sign. And G2 is the user rating size. So let's say we want to join these two together with an and sign. Okay, I mean, we've done it, but it definitely doesn't look great because ideally we want to separate the two values, 62 and 80, there's two separate values. But now when we join them together, it just looks like 6,280. So how do we get rid of that problem? How do we solve this problem? What we can do is have another data point in between these two and just make it like a space. And to specify that, we have to use quotation marks. Make sure you use quotation marks. So now that I have quotation marks, and in between is a space, single space. So I'll use a tree. Okay. So now they're separated by a space. If you want to separate them by a comma and then a space, you can do that as well. Just a comma in here. So F2, which is the first data point, and separates that in the next data point, which is in quotation marks, a comma and a space, and then add that to the second data point. And that looks a lot better. Yeah, that looks a lot better. So that those are the two ways of using the trim function. Okay, now let's look at the concatenate function. It's a pretty strange word. You might be familiar with it, or you probably are familiar with it if you have any coding experience. It just basically means adding together or joining together also. So it joins data from different cells. And so basically what it does is exactly what we did for the second trim function that we used. It's basically does the same thing as the second way in which we can use the trim function. So to not make sure it's not too repetitive, I'll cover this pretty quickly. The hardest part about the concatenate function is actually spelling concatenate, if you ask me. Like, so what we're going to do here, let's say we want to do the same thing as before. We want to join the data in column F, which is user rating score, and the data in column G, which is user rating size. Okay, this time we basically, of course, call a function concatenate. And instead of separating things by the and sign, we separate it now by just a comma. Other than that, it's the same thing. So instead of F2 and F2 comma, and then G2, let's say. Again, gives you like, joins the two numbers together, makes it look like one number. If we want to have a space, again, we have to use our quotation marks, and a space, and a comma. So now it's basically joining three different things together. The first thing is our first number, and the second thing is the space, and then the third thing is our second number. So it looks like this. Right. So yeah, that's the same, pretty similar to trim, depending on how you use it. Okay, the next one is pretty easy, but also pretty useful. So it's the left or right function. Okay. What this does is if you've done like foundations of computing, or if you haven't done it, like basically what it does is it slices a certain number of digits or characters from data point. For example, let's say you have a bunch of data, and all the years are like 2013, 2022, 1998, or whatever. But you only want 2 digits. Like let's say for some reason you only want 2 digits instead of the full year. So like 1998 is like 98. 2013 is like 13, etc. So this can help you do that. So what the left function does is it only takes a certain number of digits or characters that you want from a data point, but it counts from the left. And what the right function does is it does the same thing. It let's say you have like 5 digits in this data point, but you only want 3 of those digits. You can do that, and it counts from the right. To show you an example, let's see. First, let's try the left function. Okay, so let's say what values we want to take or we want to slice. All right, so I'm looking at column B over here. So that's the ratings like TV, 14, PG 13, etc. So let's say we only want to take 2 characters, like 2 letters out of these ratings instead of like in this case it's 5 letters if you count the dash, and we want to count from the left. So okay, so like if we want to take 2 digits out of these, do we want 14 or do we want TV? If we want TV, we're counting from the left. So that's why we want to use the left function. And the data point we're interested in is it's in B2, and we want to take 2 digits. Okay, so that should give me TV, and drag down. Yeah, that's done its job. It just like looks at the data along this column, and it takes the leftmost 2 letters. And as you can probably guess, the right function does the same thing, but towards the right. So let's say we actually want to look at the release year of these movies. So like what year they were released. Yeah, a bunch of years. And let's say we don't want the whole year, we just want we just want 2 digits from it. So if it's like 2013, we just want 13. So that's why we want to count from the right. So it's the data points that's in column E, row 2, E2, and then again, we want to keep 2 digits. So it should give me 13. Yep. And if we drag it down, it gives me all the other years as well. So very simple, but very useful function. Okay, so halfway there, and it could, right, some of the harder functions still come on the way, but some of these ones are pretty easy to use as well. All right, VLOOKUP is probably one of the most confusing ones. Just bear with me. So basically, it helps you find things by row if you have a large data set. So let's say it's something that it's a data point you want to look for. You don't know where exactly it is, but you know which row it is in. So this is when it's useful. So this one actually takes 1, 2, 3, 4 arguments. Yeah, takes 4 arguments. So first up is called the lookup value, which is basically to be honest, the lookup value does not matter as much, and you will see why as I explain the rest of this function. But and then after, but let's look at the second argument. The range is basically, okay, so what is the range of the data that you're looking at? So in this case, of course, it would just be a row, like if you're looking for things by row. And the column number is, right, this one is going to take some explaining. It basically means how far apart is the thing that you're looking for from your lookup value. And the last argument is, okay, you can input a 1 if you want to look for something that approximately matches what you're looking for, and 0 if it exactly matches what you're looking for. So I think it's best to show this through a example. Okay, so we're moving on now. Go to the second page, so functions 7 to 12. Okay, so right, so let's say we're trying to find the user rating size. Right, so the user rating size of these different shows. So okay, so first of all, the first argument is our lookup value. I'm just going to make it the first thing that is in the same row. So if we're looking for a data point across this row, yeah, lookup value, let's just make it like the first thing you see in that row. So that's column A, row 2. A2. All right. And after that, it is the range of the data that we want to look at. So for this one, the range of the data, since we're looking for things across the row, of course, the range of the data is just the row itself. Okay, so from A2 to F2. Yep, that helps me select the row in which I want to look for my data. And the next one, the next argument is the reason why I say the lookup value that you said actually isn't that important, because this is a numerical input. It basically tells me, it means how far apart from the lookup value is the thing that you're looking for. So if we label our lookup value, yeah, if we label it A2, that's my lookup value, as I have done over here. Let's say this value is let's say we call it column number 1. Okay, this is number 1, then this is number 2, this is number 3, and this is number 4. And since rating level is the one that we want, is the thing that we're looking for, so its index is basically the number 4 if this one is if the lookup value is index 1. So let's say we didn't call this A2 the lookup value. Let's say we made B2 the lookup value. That means B2 is now labeled 1, and then this C2 is now 2, and D2, this thing that we're looking for, is actually 3 now. So that's why the lookup value isn't too important. Just, I guess, preferably pick something that's closer to the actual thing that you're looking for, so you don't have to count as much. But yeah, so, but in this case, I set A2 as the lookup value with index 1. That means the thing that we're looking for, which is D2, that's the index 4, as I've inputted here. And the very last argument, you can call it a make it 1 if it's if you just want a approximate match to what you're looking for, and put 0 if you want an exact match. Drag that down. Yeah, it gives you the rating level for all these different shows. Yeah. So it's in this case, like, it might seem a bit stupid to like use something seemingly so complicated with something that's pretty simple. But I guess when you have like a very large data set, if you encounter a very large data set, this could be pretty helpful. I tell you that, okay, so you know what your lookup value is, you know this value in the across the row, and you know that the thing that you want is like 20 spaces across the row. Okay. This can turn out to be pretty helpful. Or even when you're like trying to sort of reorganize the data. Maybe right now these two values are like 20 columns apart, but you want them to be like right next to each other. Be helpful as well. So many different uses. Okay, this is probably the most confusing function. So we've gotten it over and done with. After that, it's pretty actually pretty easy. So okay, number 8 is the if error function. Again, the if statement. So we know it's basically checking the criteria. So the criteria in this case is if there's an error. You don't have to define the criteria yourself. It's basically like if something is like when you do a math equation, if it's undefined, or like if you do something to different texts and it just and it can't do that, it will result in an error. And this basically allows you to sort of customize the message you receive if you encounter an error. It takes 2 arguments. So the equation, or like the value which we want to check for whether the error exists, and an output if the error does occur. So only 2 arguments. This one is also fairly easier. Okay. So all right, over here, let's forget about a big data set of like Netflix shows. Let's take a look at yeah, this data set. It's a very small data set. So basically what we're trying to do is trying to divide the number by the divisor. So 10 divided by 5, we know that's 2. We know that's 2. 10 divided by 0, that's undefined. So we're sort of expecting an error there. 10 divided by nothing, should also expect an error there. Nothing divided by 5, that's an interesting one. ABC divided by 5. ABC, like it's not a number, so it should also result in an error. So we can check for that with our if error function. If error. So let's say we want to check. Okay. So the value in this column divided by the value in this column. So K3 divided by L3. So that's the equation that we want to check for if there's an error. And then if there is an error, let's say we want to just output error. Okay, so the first one doesn't have an error, that's nice. And the rest, okay. The rest, okay. As expected, 10 divided by 0 and 10 divided by nothing results in an error. But interestingly, nothing divided by 5 actually gives us 0. And all right, this is something else that you should know about Excel. So if you have an empty cell, it's sort of like, even if it doesn't show, by default, it reads it, or it interprets the empty cell as a 0. So over here, we have empty cell as well. Excel basically reads it as a 0. So 10 divided by 0 is the same as 10 divided by nothing into Excel. And of course, you can't do either of those, so they both result in errors. And nothing divided by 5 is the same as 0 divided by 5, so that's actually not an error. It gives you 0. And ABC divided by 5, that's obviously erroneous. And you don't have to like have error message if you don't want. Sometimes it can be like annoying to have these error messages. You can just have a empty string, so empty quotation marks as your error message. So, okay, nice. So if we get a successful output, the output is there. And if we don't get a successful output because there's an error, then nothing happens. The cell is still empty. Instead of like a error message, which you're gonna have to like fix and delete or whatever. Sorry, but okay. Oops. Let me just change again on empty string. There we go. So we have two successful outputs, and the rest of the those 3 are errors. And if we have an error, we can say that just don't output anything, not even an error message. Yeah, there's that. Okay. And next up is the value function. Also very, very, this one's probably of the easiest to use, easiest to remember, but in practice, when you actually use it, the result can be a bit confusing, because what it does is it converts data to a numerical value. So I made a separate like path data just to show this. So yeah, let's say we have these things. So we have a some money over here, $45.50. We have a date over here, which is the date of today. We have time. We have 95.5%, which is hopefully everyone's WAM. Yeah, maybe that's the case. And another monetary value, also another date. And then in the end, we actually have something interesting. We have a word, or like a text, hello. So what if we try converting hello into a numerical value? See what happens. But let's convert all of these into a numerical value. So just the value function, it only takes one input. So in this case, it's column O and then row 3. Yeah, it's sort of like it's pretty, nothing should surprise you. $45.50 becomes 45.5 as a numerical value, but the rest can be a bit confusing at times. Yeah, so the date becomes something that I don't know what algorithm is used to convert the date into something that looks like this, but and okay, this is interesting. So it actually says that the converting a time into a numerical value doesn't work in this case. But okay, if we separate the like AM or PM with the actual time itself, then we can do it. But if we don't separate it, results in an error. It's pretty interesting. And 95.5% becomes 0.955. And yeah, the dollar amount just becomes the same thing, but without the dollar amount. And then, yeah, interestingly, you can see that these two cells are the same. So after taking these two different ways of writing the same date as the argument, the value function outputs the same output. So it reads these two as the same. And the only error that we come across is when we want to use the value function with a text like hello, or like any word, or any paragraph, like basically anything that's like non-numerical. What you can realize is that when using a value function, like a lot of these data points, like all these data points already have some sort of numerical value, even if it's not like just like a pure number by itself, like dollar signs or like time of the day, percentages, for example. But if you just give it something that doesn't have any numbers already, like hello, it's going to result in an error. So yeah, that's the value function. And okay, oh, isn't this nice? So many functions that only take one argument. So that's pretty easy to use. So unique, this is quite useful. The unique function, what it does is it scans a very large range of data and it only gives you the outputs that are unique. So let's say, well, so coming up with an example on the top of my head, let's just look at the actual data set we have here. The of stuff. Okay. So here we conveniently have the title of each Netflix film and its release year. And obviously there's going to be films that are released on the same year, right? So this one, I don't know what that show is about, but this one's released in 2013. This one's also released in 2013, and I'm sure go down and also find other stuff that's released in 2013. So, oh, Breaking Bad, well, that's good. Okay. So let's say we're going to use the unique function. What this can allow us to do is to find all the unique years in which a movie was produced, or in which a Netflix film was released. So even if it's even though it's just one argument, it's going to be a pretty big argument. We're going to look at this whole range of data sets all the way down to the bottom. I believe there's 200 and let's just check how many rows we have. 245. Okay. That's in okay. So I the way to I 145. Oh, silly me. But the most important thing, which is you actually have to have an equal sign. We call a function. 45. Yeah, so that basically selects the all the different years in which all the different films were produced. And if we use the function, as you can see, instead of having 245 different values, we have less than 245, because now we've actually outputted all the unique years in which a movie was produced. So 1999 won't appear twice. 2013, it won't appear twice. It just looks at all the unique values. All right, 2 more to go. Okay, sort is also quite helpful, quite straightforward as well. It sorts values in either ascending or descending order. So it takes, it technically can take 2 arguments, but one of these arguments is, the second argument is optional. What I mean by that is like, you can just use the sort function and select the range of the data which you want to sort. And by default, it sorts it in ascending order. I can show you through the data set over here. So since we already have these unique years, might as well just the sort function on these values. So let's say we want to sort, okay, we'll sort all this data. What it's going to do is sort it in ascending order from the earliest to the latest, from the lowest number to the largest number. In other words, in this case, it's just the earliest year in which a film was made, like the latest year in which a film was made. So it can just take one argument like that. Be careful though. It can't be a single data point, because how are you going to sort a single data point with itself, right? It's not going to change anything. Like it has to be, you have to select a range of data as one argument, and it's going to look through those that range and spit out the values in ascending order. And if you want to split it in output these values in descending order, of course you can do that. Again, I'm going to select the same values, except this time I can add an extra argument, an extra optional argument. say -1. And what that does, oh, what happened here? That's strange. Right, I have done something wrong, sorry. That is weird. Let me try it. Three to here, 33. Wow, that's very strange. Sorry, I'll get back to that. Hopefully, might have made a mistake on my part in preparing, but yeah, I'll figure out how to sort this on in descending order as well. But for now, let's look at the filter function, which probably is arguably one of the harder ones in here, similar to the VLOOKUP. Can be pretty bit confusing at first. So basically, filters data based on criteria you define. So again, you define your own criteria, and let's say you have a huge data set, like many different rows and columns. You only want the rows and columns out of that data set that fulfills your criteria. Then this is the function that you can use. So the range to output, you can think of that as like the overall big data set, all the rows and columns at the start. And then, yeah, and then next up is the column in which you want to check if the criteria is met. So you maybe like each column represents different criteria, like year, or like ratings number, like and etc. And yeah, so you want to set the column in which you're going to check for the criteria to be equal to the conditions of the criteria. And yeah, I'll show this through an example. Filter. Okay, last one. So all right, let's first think about what is it that we want to do. Let's say okay, let's say we want to take all this data, like from all the way from A to column A to column F, all the way from row 1 to row 264, I believe, 65. So all this big chunk of data, but we want to just output the data that fulfills the condition of having a ratings value exactly equal to 90. So we're just gonna basically get rid of all the rows that don't have a ratings value equal to 90.
Sorry to interrupt, Andy. Can you switch to Excel, please?
Oh, okay, my bad. Thanks for pointing it out. All right.
Good, all good.
Okay. So we're basically looking at this whole chunk of data here. So all the way from like, yeah, column A, column F, from row 1 all the way down to like row 200 and something, this whole chunk of data. So this time, like the filter, what makes the filter function a bit different to the other ones we looked at, it's like the other functions sort of are interested in outputting certain data points or certain values based on our criteria. But the filter function basically tries to keep the overall data set, but it filters out, it gets rid of the stuff that you don't want and keeps the big chunk of stuff that you want. So let's put it into action. Filter function, okay, equal to filter. Our first argument is going to be the entire data set. So A2 all the way to F are 265. So if you so I've basically, by doing that, I've basically selected the entire data set that's basically in blue right now. And then next up, my criteria is that, as I said before, I only want the shows in which rating value has a I only want the data related to shows that have a rating value exactly equal to 90. So I'm going to first scan the column, the whole column of D, because that is the column that contains these rating levels. So from D2 to D256, and criteria is that it has to be equal to 90. Oh, sorry, equal to D2. D2, same as 90. All right. So now if I use this function, okay, I get a lot of data. So yeah, as you can see, it just outputs. It doesn't have the same starting as the big data set over here, but it keeps all the info except it's filtered out all the stuff that doesn't have a rating value, a rating level as exactly that's exactly 90. Okay, so yep, that's about it. Let's now I should try to figure out how to sort these things in descending value. Okay, thanks to Owen Jackson, who I think figured out what's happening. Oh, okay, so 2 comments instead of 1. Let's give that a try. Maybe you should be teaching a class, Owen. But okay, let's try 2 comments. There we go. All right, a round of applause for Mr. Owen Jackson. All right, thanks, mate. You saved me a lot of embarrassment. Actually, probably nothing can save me from the embarrassment, but you did save the class. Anyways, yeah, so that's the basic overview of the 12 functions that we have prepared today. And I hope that yeah, I hope that's like throughout my explanations, everyone has been sort of jotting down their own examples, or at least like following along with the same like functions that I've been using. So you can always look back to this document in the future for your own reference if you want to like review any of these functions. I'm sure it'll be helpful in anything that's I guess related to like numbers or like big chunks of data in the future. Hopefully like you find benefit in this in your future studies, like assignments or like in career. And yeah, that's about it from me. Thank you so much, everyone. Do you have any more things to add, Scarlett?
Yeah, so thanks everyone for joining. I just chucked the feedback form in the group, in the chat box. It'll be great if you guys can leave us some comment, and the recording will be sent straightly to you guys if you complete the feedback form, so you don't have to wait until the YouTube. I guess I'll just jump into comment on some shortcuts when we're using Excel. They're extremely useful and they'll save you a lot of time. If you know the shortcuts, then you definitely know what I'm talking about. So I might just use the same Excel sheet that Andy shared with you guys. So if you feel free to leave, it'll take roughly like 10 more minutes for me to introduce those shortcuts, but they're pretty useful. So the first one I want to show you guys is if I do just like a random function, it can be like any kind of function that Andy introduced in this workshop. Then if I'm just going to drag down, then it's going to take me a lot of time to go drag all the way to the bottom, right? One thing you can do is you go to the right bottom and you just double click. Oops, it doesn't. Okay, give me 1 second. So, oh, that's strange. But usually if you double click, so if you enter a function, then if you double click on the bottom right corner, it should go all the way down to the end. Let's try with another one probably. Yeah, so I'm not sure why this one doesn't work. It's probably like it's within that data set. But usually in the Excel, if you enter a function, like whatever function you enter, and you double click on the bottom right, it should go all the way down to the bottom. Okay, that's one shortcut. The other one is, so say it's very hard for me to scroll back up to the top and see, oh, this is the title, this is the rating, this is the description. So if you go to view, then you can see there's a freeze panes. If you just click on that and say, if I want to freeze the top row, and it's frozen. So it doesn't move while I'm scrolling down. So I don't have to scroll up all the time to see what the title is. And if you want to freeze the first column, you can do the same. So if the form is very long, you can do that as well. Then, so just let me unfreeze it and say if I want to freeze the first row and the first column at the same time, I can click on this this box. So it leaves one column and one row. Then I can click on freeze the first option and it'll be like this. So the first column and the first row is frozen. Okay, that's about freezing panes. Next one I want to show you guys is, if I just go to home. So it's actually very similar to the sort function. Andy showed you guys another way of doing it, like sorting the numbers, which you definitely can. But there's another way of doing it. So if you just go to home and you go to sort, there's like a shortcut of it. So say I want to, in ascending order, I want to rate to the rating level. So you, it's automatically sorted to in a ascending order. And if I go to descending, it's automatically to descending as well. Okay, just let me go back. Then the next thing I want to introduce is the filter function. So I think it's very similar to the filter function that Andy introduced just now. But if I just click on filter, you'll see like this, like little arrows here. And say, if I click on the arrow and if I want to, like, give me a second. If I only want the 2001, so filter this item only, you'll have all the rows that contains the release year of 2000. And if I cancel, so I click clear and it's cleared. And I can also choose multiple. So say I want to choose these 2 years, then click OK. Yeah, it'll just give me like this 2 years. There's whole different ways of doing it. You can choose top 10, you can choose above average, below average, depending on your need. Another very cool thing about filter is, say if you're working on a data set and like the data set is very huge, and I just want to sort of annotate what sort of data is important for future reference. So say if I just want the rating level to be 100, 110, and 124, and I click OK, all the rating level above 100 will be selected. And if I just choose all of them, then say I want to give it a color, say yellow. Okay. Then if I go back, if I clear all, it's very hard to find those values, right? So instead of rating by numbers, you can actually filter by color. So if I just click on the yellow one, you can see it's automatically selected for all the yellow items. All right, I think that's all I want to share with you guys about the shortcuts.